Hey, everybody. Thanks for listening to the Metis Tech Show. Today, we're going to be discussing more A2L, what we've learned so far. But first, the Metis Minute.
Today's Metis Minute is on Hall effect sensors. A Hall effect sensor works by detecting changes in a magnetic field. Inside the Mitsubishi fan motor, the rotor's permanent magnet sweep past the Hall element. The magnetic field shifts the flow of electrons, and the sensor's electronics turn that into a switching signal. For example, wires 3 and 4 may supply the Hall sensor with 15 volts DC and ground so it can operate. Wires 7 and 4 carry the feedback signal. The sensor itself doesn't generate 15 volts, it just pulls wire 7 to 0 volts when a magnet is present. The control board uses a pull-up resistor to hold that wire at 15 volts when the sensor is off. As the fan spins, this creates a 0 to 15 volt square wave. The board counts the pulse to calculate RPM and check that the fan is running at the command speed from the 0 to 6.5 volt speed control wire. Thanks for listening to today's Metis Minute. Now let's start the show.
The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The Metis Tech Show.
Mitsubishi.
It's been a while since I've been on the show. At least it feels like it.
That's probably why no one's listening.
Oh, yeah.
But you've been on.
I doubt it.
You were on.
It's been a while. It's been a few.
Well, let's look at the last couple of... I don't even know what we did for episodes.
Going from like doing, every episode. Now we got Bryn. So I can kind of, he takes care of Bryn with a mustache.
Yeah,
now,
he's a new podcast
which I
baby.
can't get past. I don't know.
Oh, no,
I
told him yesterday. Tom Selleck would be proud of that.
Yeah, definitely.
Going to the NASCAR race in a couple days. So, or actually in a couple weeks. It's on the 21st of September.
So I know nothing about NASCAR, but I know there's one guy that gets booed every time and he likes the booze. That's all I know.
I don't know who that is.
Okay. I could have been tennis for all I know. It was just somebody thought they had a race. I don't know. Don't listen to me.
I mostly just do it because when you go, like I grow out the mustache. Last year I did a mullet, and basically we just kind of really play the part. It's almost like Halloween, but specifically for NASCAR. It's fun.
You probably just offended a bunch of NASCAR fans. So what's this you cooked over the weekend? Some type of new lasagna?
Yeah, so you get these recipes that pop up on TikTok or whatever, and it just catches your eye. So it was cheeseburger, and actually the correct term was garlic parmesan cheeseburger lasagna. So it's like, whoa.
I like all those words.
Yeah, and the picture that was on there, I like my lasagna al dente. I don't like it where it's sloppy and you can't cut a piece without all the cheese and the sauce running everywhere. That's just the style lasagna I like. So this kind of appealed to me. I was like, I'm going to try this. And the kids were all excited that this is going to be good. It's got to be delicious. And one of the ingredients is putting together a roux with some flour and butter, and then you create this Parmesan sauce that you put over the hamburger, and it gives it this saucy gravy type filling.
Did you use real Parmesan or the shake cheese?
I used real Parmesan. Good. It was grated, but it was from the little cheese kiosk at the supermarket, so that makes a big difference.
Oh yeah, no, the shake cheese has cellulose in it.
Yeah, plastic. I even used block mozzarella. Grated it myself, not grated it, but shredded it myself. Shredded some cheddar cheese, and you're just layering the lasagna like you would any lasagna. The binder is marinara, so it's still got the sauce in there. But
did you make your own sauce, or did you get a jar?
I got a jar. I didn't have time to make sauce.
What brand did you do?
Newman's.
Newman's.
Paul Newman's. He's got some good stuff.
Yeah,
the coffee, the sauces.
My favorite jarred sauce. Though I like to make my own, but when I don't, it takes time. Rayo's.
Oh yeah.
It's double the price, but it's worth it.
Yes, yeah. You can tell the quality when you're spending money on the marinara.
Do you pre-cook the pasta?
I do. I see. I've done it without pre-cooking.
That's a big scam. They sell lasagna noodles that they say no pre-cooking needed. and they charge you extra for those, but you can get the regular noodles. They don't have to be pre-cooked, and I've done it both ways, and I don't notice a difference.
See, the thing is, I think you can use dry noodles right from the get-go
Yep,
in the pan if you have enough sauce in there.
Yes, you need
With
liquid.
the cheeseburger lasagna, you're not going to get that steam or that sauce to cook the noodles through enough. And I think they're probably going to be a little bit, undercooked. So, but anyway, it came out fantastic. The kids were like, "Dad, don't ever make another lasagna unless it's like this." And I was like, "Well, it's not really Italian lasagna.
It's not lasagna.
It's
a
kind of
lasagna-esque.
a,
It's lasagna-esque.
yeah."
I actually had a friend make me a lasagna soup the other day.
I've had that.
So like in
Really,
a crock pot, but it had the lasagna noodles and all the ricotta and sauce and everything. It was fantastic. I think there was some ground beef in there too.
yeah, I
You ever
love
had
lasagna.
lasagna hamburger helper?
No, I don't live in a trailer park, so we don't use hamburger helper.
Wow. Yeah. No,
Can I
it's,
say that? I just offended trailer park people. Huh?
Yeah, that was
It's the same as the NASCAR people.
that was terrible, Paul.
I know. My wife actually. There's a story behind that. I was at the office one day, my previous employer, and all the instructors shared the same office. And she calls me up and she goes, "Would you like some hamburger helper?" I said, "Sure, if you want, but we don't live in a trailer park." And then the guys were listening. What is that all about? And they thought that was funny and insulting at the same time.
No,
It's,
you insulting? I don't think so.
no, but I like lasagna. I love lasagna, but I will never get lasagna in a restaurant because you never know what you're going to get because there's 1,000, maybe 1,000,000 different variations of lasagna. And I just, some of them are too cheesy.
Yeah.
I love ricotta, but there's a limit. Some just liquid ricotta coming out of the thing when you cut it.
And what's the chances that you're getting fresh lasagna?
Oh, yeah.
You're getting something out of that someone's scooping out of a pan, probably
yeah.
reheating in the microwave.
Oh, yeah.
Who knows?
They made it. They made it a week and a half ago. It's still there.
Yeah.
Yeah. No.
Yeah, the freshest places they made it that morning. That's best case scenario.
Yeah. And one time I got invited to somebody's house for dinner, and they made eggplant lasagna. And I think you guys know how I feel about eggplant.
Yeah, no.
And that was like, it really had. I mean, I had to be polite. I was dying over here. I was like,
Yeah.
how do you,
No.
no dog around,
Yeah,
just
deep
awful.
fried eggplant and then throw it in the garbage.
Exactly. You're like, what's that guy that turkey bacon goes in the garbage
Right.
show?
Yeah.
That's Parks and Recreation.
Yeah, that's where turkey bacon
What's his
belongs.
name? Ron
Ron
Swanson.
Swanson,
Ron
yes.
Swanson.
Yeah, that's. I've never
He-
seen the show, but I've seen that scene, and that's a great scene.
Yeah, he walks into Lowe's and he says, "I know more than you."
Yeah.
Which is probably true.
Yeah. He's like, "You need help finding something, sir?" He's like, "I know more than you."
Yeah.
Like, okay.
All right, so what are we going to talk about today?
So welcome to the Metis Tech Show.
I always forget
It's
that part.
so great to be back on the show after a year. No, it's only been a month.
No, it's probably been probably a
Been a
week
busy
and a
man.
half.
What are we talking about?
Well, first of all, we got to change here. So for those who are listening, you're listening to the same thing we've always done, but this is the second episode that we're actually making a video version. So if you go on YouTube, you go to the Metis Training Network on YouTube, you actually, my apologies ahead of time, but you get to see what we look like.
Yeah.
And we got these Corinthian leather couches, or sofa seats.
Rich Corinthian leather.
Rich Corinthian leather. These are fantastic.
Now, I should tell everybody, in full disclosure, this is not going to be every episode. It's when we can, because sometimes we take them on the road, and we're not going to pack all this stuff up and take it on the road. We need a semi-truck to pack everything up.
Yeah.
Yeah.
So we're not going to be doing this for every episode, but when we can, there will be video. We'll try to do this when we have episodes that we need some graphics to show so we can explain. I think, Bryn, we're going to do that for this one, right? We
Yeah.
got some slides.
Yeah, so
that
that's
we're
one of the
gonna be
big
showing.
Yeah, that's one of the big motivations for doing this. Is now, those audio listeners. Sometimes we're talking about a manual. Like, do you guys remember the refrigerant adjustment mode? That was such a hard podcast to just discuss. But if we
Right.
had the flow chart up during that podcast and somebody
Yeah.
could visually follow along, it would have been so much easier, I think, for the listeners to kind of grasp. And so what we're trying to do here is essentially when we do these and we've got some graphics that we want to show, whether they're slides or, screenshots from a manual,
Absolutely,
we can actually
yeah.
pull them up. So if you are a listener and you get kind of lost in the weeds sometimes because we jump all over the place, we're using the YouTube videos in order to give some visual aid to what we're talking about.
Just like
And keep us on track.
my socks that I'm wearing today are my guitar socks.
Yeah.
At least you're wearing pants. At least you're wearing pants. That's
yeah.
good.
That's a good thing.
So if you're sitting there and you're staring at your windshield and you're listening to us and you want to see what we're talking about, see a graphic, go home. Don't do it while you're driving.
Yeah.
Pull over, go home, bring up YouTube, Metis Training Network. You'll see the episode there, and you'll see some graphics go along with it. Anyway,
Got it.
so today, and this was Bryn's idea, and we've done a bunch of A2L podcasts at the beginning of this year, end of last year. But now that we're, 9 months into this, there's some of the things that we've picked up that we want to just explain.
Yeah.
Bryn, so let's talk about the first one.
Yeah, so this actually came about, and it just happened to be something that I kind of noticed when I was going through the install manuals for the multi-position air handlers. And what we actually found was it was causing issues in the field too. It was kind of an overlooked part of the installation of a multi-position air handler. And that is that depending on your orientation of that air handler, you need to move that refrigerant sensor.
Right. It comes mounted for upflow.
Yep.
Right. If you're going horizontal right, if you're going horizontal left, or if you're going downflow, you need to move it. And I think the important thing here is if you're going horizontal left, the sensor now is underneath the evaporator coil.
Correct.
And that could drop water on it, and water on an electronic component, no good.
Right.
So you need to move it. If you're going horizontal right, it's going to be on top. That's what I did at my house. But you still need to move it so it detects the refrigerant leak. Now, you're not so much worried about water, but it still has to sense the refrigerant. If there's a leak and the fan's blowing, it needs to be in that airflow path.
Right. Yeah. You may not get the sensor error because the sensor fails because water's dripping on it, but now you're not accurately sensing the airflow. Right. Where it's located when you're horizontal right, it's not downstream of the coil. It's basically right in line with the coil. So if there's a leak and you've got air pushing it into the ductwork, sensor's not going to see it. So we got to relocate that to basically where the supply plenum takes off. There's depends on the type of unit you have. If you have the SVZ, you're essentially in the install bag. There's this little metal bracket, and that metal bracket gets used. You take the sensor out of its current location, put it in the bracket, and then that bracket will clip on to there's a little lip essentially right where the top of the SVZ is, and it's going to clip on the bottom side. So if you go horizontal left, it's going to go on the bottom side of that coil, horizontal right, bottom side of that coil, and it's just clipping in.
Yeah. And the time to do this is when you unpackage it before you attach the plenum to it. You want to make sure you do it because it just becomes more difficult once the ductwork's attached.
Yeah, I mean, almost impossible once the ductwork's in. I mean, you might be able to get to it from the cabinet, but you're going to be reaching around the coil to try to get in there. So should be, I mean, realistically, when you do an installation, look what's inside the install bag. We don't just throw stuff in there for fun. If you ever try to install an IntelliHeat, same thing, right? We have a ton of components inside that install bag, and a lot of them are required for installation. It's the same thing with the air handler. Look at that install bag, see what's in there, because there's also vinyl hoses in that install bag for the air handlers. Because if you go horizontal left, I believe it is, you need to reroute the drain water.
Yeah.
And so you need components in there. You're going to run into problems if you don't take a look first. So just get in the habit of when you're doing installations, look at the install bag and see what's in there and try to figure out why it's in there.
Yeah. The install bag is not something for you to just use as a knee pad to kneel on.
No.
So if the contractor does nothing with left horizontal, right horizontal, repercussions are going to be basically no refrigerant sensed,
Correct.
or the sensor gets damaged by water.
Yeah.
Okay.
And that's when it kind of got discovered on the service side was a lot of people were failing to do that. And with the horizontal left applications, they were getting water on them. And then they were like, why are we getting all these failed sensors on the air handlers? And it turns out it's because we weren't relocating them.
Yeah, and this is in the manual. And it's also, I believe there's something, there's a notice on the A coil itself.
Yes.
But if you don't open that up and you don't look at it, you're going to miss it. So make sure you open it up, you look at it. And this is for the multi-position air handler. It's for the PVA or the SVZ.
Yep. Yeah, the difference with the PVAs is, and also the 4 and 5 ton SVZs that are coming out, is that they're going to have, you're basically going to be reusing the same bracket that the sensor comes in. But with the PVAs and the larger SVZs, the 4 and 5 ton, there's actually pre-drilled holes. So you're taking that bracket out of the coil plate and you're screwing it into the pre-drilled holes that are inside the cabinet. SVZ, separate bracket comes in the bag. They just get clipped on.
All right.
Good to know.
Yep. And the next thing we're going to talk about, and we're going to go to the smart multi now, and what are the steps that happens once it senses refrigerant, right?
Yes. Yeah. So there's just, this is something that we've talked about in the previous podcast, but I just think it's nice to kind of have it all laid out now that we've actually been able to see it happen and test it. So basic steps. Number one, when we detect refrigerant leak, we're going to switch to cooling mode, and then SV4 is going to de-energize. SV4 is our liquid line solenoid valve. Then the compressor is going to start. The system's going to begin to pump down. And what it's doing is it's looking at 63 LS, which is our low pressure transducer, and it's looking for it to hit 30 PSI. Once we hit 30 PSI, SV5 is going to de-energize. And then after about a minute or so, the compressor stops. The fans will blow for another minute or so, and then that shuts off.
And you're pumped down, and all the refrigerant is in the outdoor unit.
You got it. Yeah, so that's the plan, right? We're just pumping down that refrigerant to the outdoor unit. Now, what's actually cool is in class one time, I had the smart multi operating, and I actually unplugged one of the sensors. And while I did that, we also had the dip switches on SW4 set to look at the low pressure. And then I had
you
them
got to watch everything.
I had them with a meter looking at SV5, which is our gas shutoff valve. And as it came down, we were watching that pressure come down during the pump down. And then almost as soon as it hit 30, you hear a click, and then the voltage dropped out.
That's cool.
So we
is
actually
this-
got to verify how that
So
works.
I'm a little confused, so I'm probably the only one. But when you're talking about a pump down, is this just a normal pump down on the off cycle, or is this a pump down you're talking about for a leak detection?
This is if a leak is detected.
A leak is detected,
So we
okay.
call it refrigerant recovery control or
Right.
refrigerant recovery mode. But yeah, it's essentially the same thing that you would do if you had a unitary and you were pumping it down. We close the liquid line, run it in cooling until we get down to low pressure.
No, if I had done my job, I would have read through this sheets you gave me ahead of time, but I didn't.
Yeah.
Does the system pump itself down on the off cycle? There's no indoor unit calling. Does it pump down then?
It can. So if depends on how you have your dip switches set, the manual tells you to turn on 6-6, which is it's a dip switch that essentially any communication error can also cause the system to pump itself down. So if the system's not calling for anything, but a comm error comes up, it can pump itself down. Now, it doesn't do this every time we shut off, right? So if we don't have any refrigerant leaks and all of our units satisfy and the outdoor unit shuts off, it doesn't pump itself down. This is only in the event that we have a refrigerant leak, a refrigerant sensor error, or we have a communication fault and 6-6 is turned on at the outdoor unit.
Okay. And what's this note here you have on the slide about SV4 and SV5 re-energizing?
Yeah, so this is a little bit confusing. Those are power open. So what we originally thought were if the power was on, those valves were open. But that's not necessarily the case. If we power down, we find our leak, we repair the leak, we pressure test, we triple evac, and we add in our trim charge. When we power back on, those solenoid valves are still closed. They stay closed. The only time that they open back up is when we have a call. So we got to make a call for cooling. We'll see SV4 and SV5 energize.
Your SV4 and SV5 are the solenoids that are right in line with the service valves.
Yep, they're right after the service valves.
Okay. Now, big surprise. Let's see what's on the next sheet here.
Yeah, so this is just talking about the steps necessary for if you do have a leak. So let's say you have a leak at a fitting at the indoor unit. It's just talking about the steps that you should take to properly pressure test, triple evacuate, and recharge the system. So step one would be the system will need to be pressure tested and evacuated. So we want to treat it as two different systems, right? So the way I like to think of it is you have your line set and heads, that's one system, and then you have your outdoor unit, that's the other system. And you're going to treat them two different processes. Pressure test the outdoor unit, pressure test the line set and heads.
And this is because SV4 and 5 are closed.
Closed with the power off.
Even if your service valves are wide open, fully back seated, you still have those valves closed because they're not energized. They're energized open, power open.
Yeah, exactly. And I would recommend actually leaving your service valves open because of this.
Right.
And the reason why is because there is a small space. If you close your service valves and you pressure test, there's that small space between the solenoid valve and your service valve that won't get any action, right? Because you've got a closed service valve, closed shutoff. There's no way to pressure test that section.
Right.
So leave your valves open. The solenoid valves are going to be closed. Pressure test everything. You can triple evac through either side. And then on the outdoor unit, you're adding your factory charge. On the line set and head side, you're adding your trim charge or additional refrigerant charge.
And just to make sure, we're talking about if we've done a repair, we've opened the seal system, and now we're starting over. We're pressure testing, we're evacuating. This is not a startup.
And this is the smart multi.
And
This
it's
is not
smart
every
multi
system.
only.
correct.
You got
So,
it.
Yeah. So just to be
in case
clear.
everybody listening is like, I got to do this to every system. No,
No,
this
no.
is the,
It's just the
talking about
smart multi, the multi-zone.
Yep.
Smart multi.
Yep. The rest of them don't have the means to pump themselves down. The reason why we have the smart multi be able to pump down is because it holds so much more refrigerant. So we need to be able to remove that refrigerant from the space. Otherwise, we'd have these large room requirements just because of the state of the type of the refrigerant.
So I hope I'm not opening a can of worms here, but you said treat them as two systems. So I'm going to pressurize all the indoor heads and the line set. And I'm going to pressurize the outdoor unit, right, through the true suction and the true discharge ports. Why would I do that instead of just energizing SV4 and SV5 and doing the whole system at once like I used to?
You could. You'd have to make good sure that you don't have leaks somewhere. Or I'm sorry, you don't have a system calling. But then again, remember, those still stay closed when you power on.
Right. I have to have a
So you'd have to make a call before those solenoid valves are even going to energize.
which means the compressor could run and you don't want
Correct.
that.
Yes.
Okay. You see, that's why I wanted to ask that. just to
Yeah.
make sure.
Yeah, they stay closed when you power on, and they'll stay closed for hours until there's a call. Only when there's a call does it actually energize those solenoid valves. At that point, you've got a compressor running, and you could have air in the system or contaminants or whatever. So not a good idea.
best practice after you repair a leak or you open the seal system for any reason is to treat them as two separate systems.
Yep.
Pressurize indoor units and line sets, pressurize the outdoor units separately, do your evacuation separately, the same thing.
Yep.
And then after you put your refrigerant in, because it's a weigh in, you weigh in the actual amount, you look at your DSB, tells you what the charge should be, and then you weigh it all in. Then the valve's already open, then you can energize, call for heating or cooling, and everything will work fine.
Yeah, and the funny thing is because I've tested it at the in the training center here, when it does pump itself down. Let's say it was for refrigerant sensor error, not necessarily a leak, but a sensor error, like one gets unplugged or a wire gets broken or something. After the repair, all of the refrigerant, we didn't leak any refrigerant, so all the refrigerant's in the outdoor unit. When you make a call for heating or cooling, it sounds just like the first time you open up the service valves. You'll hear that whoosh of the refrigerant going into the indoor units. It's kind of interesting.
Yeah. Now, I know this is coming up on a slide. I'm willing to bet you it is. But now let's talk about, because we're on the topic. So now I've got a system, it's a brand new install. I've pressurized the indoor units. I've pressurized the line set. I do my triple evacuation. Right? Now I'm going to open my service valves. But SV4 and SV5 are closed, right?
So on a brand new installation, yes, you can open up your service valves. But remember, the outdoor unit is pre-charged. So we're going to treat it like any other smart multi. You're going to add your trim charge into the line set and heads.
Correct.
And then power on. If you can't get enough in there, then at that point you may want to turn it on and then run it so you can feed whatever
Compressor can suck it in.
whatever refrigerant you need to add additionally. But hopefully, if you get a deep enough vacuum, you should be able to add your trim
Right.
charge.
But I think what's happening in the field is some contractors are doing that, and they open the valves, and they don't hear the refrigerant go through, and they say, hey, there's no refrigerant in my outdoor unit. But SV4 and SV5 have to be energized to
Correct.
open to do that. So that's the next step, is to make a call.
Yeah, don't fret. Just because you open up those service valves, you're not going to hear the refrigerant rush through the system like we would typically see because of the fact that those solenoid valves are still closed. They're not going to open until there's a call.
But to your point, you got to put the trim charge in. What better time to put the trim charge in than when the indoor unit side is in a vacuum?
Yeah.
And what a lot of contractors make the mistake of doing, and I've done it in the past, open up my valve, send all that refrigerant into the other half of the system, and I'm like, now I'm fighting to put that extra trim charge in.
Yeah,
Right?
and thankfully, I mean, Mitsubishi, we have the true suction, so it's not as bad because regardless of mode, we can still charge through that suction port. But, there be systems I've worked on where you're trying to, it's middle of winter, you can't get the thing to run in cooling because the room temperature is so cold, so it doesn't want to run in cooling, and there's almost no way you can get it in on the heat mode because that's your high pressure now. So
And you're going
that
to take
could
your
be a nightmare.
torch and heat the refrigerant tank.
Yeah.
I'm just kidding. Don't do that.
No.
that's not allowed.
But even then, you put the torch to it, you can mic it up to like 140
Nobody,
psi.
you can't put your torch to it. It's not allowed. Not a good practice. No one does that.
Nobody
Does that.
Nope.
All right, what's next?
So just because we're on the topic of those solenoid valves, one thing that you and I learned on Friday, SV4. I had not only some of my fellow technical instructors ask about it, but I've also had service guys asking about it and contractors who come to class ask about it. What is going on with SV4, our liquid line solenoid valve?
This was interesting because I saw emails going back and forth about, hey, this SV4 is closed in heating mode. How is this actually operating? And I didn't quite find out what was going on until after, you guys were talking about a check valve in this solenoid, which is interesting.
Yeah.
I've never heard of a solenoid valve that had a check valve in there. So it's energized, it's open, refrigerant can flow in either direction. But when it's de-energized, it has a check valve in it to allow refrigerant to flow in one direction. I've never heard of it. I've never seen one. But kudos to our DSG, Sean Dorsey in Salt Lake City. He figured this out before anybody.
Yeah. So I was just going to say that is, I asked Austin Bloom, one of our resident experts, and he said, oh, yeah, Sean Dorsey figured this out about 6 months ago. And I was like, all right, great.
Yeah, we should have asked him.
Yeah. So, basically that check valve is facing the outdoor unit. So we're checked to the outdoor unit, which means liquid can't exit the outdoor unit to the liquid line. That's where the direction of that check valve. So in heating mode, we don't have to energize SV4 because we're going to be pulling back liquid from our indoor units, right? That's our condenser. So we're coming back as a subcooled liquid to the outdoor unit. But because the check valve is in the right direction, we can flow into that outdoor unit with solenoid valve 4 de-energized. It's allowing that flow. The problem is when we switch over to cooling, now we're trying to send liquid from the outdoor unit to the indoor units. Well, because of the check valve in place, it's just going to deadhead. So when we energize SV4, it pulls up the check valve, pulls it out of the way. So now we can flow.
And that's called a bidirectional solenoid valve, which, again, never heard it before.
Yep.
Never heard of it before Friday. So you learned something.
Yeah. Well, when I heard bidirectional, I was like, well, of course it's bidirectional because it goes both ways. We can have liquid or gas go in either direction. But
as long as it's open.
There's a nomenclature about those that essentially means it's got a check in there.
Yeah, so don't fret because it didn't make sense to us because we were sitting there watching it, and we're in the training room. He's got the meter on there. We're doing this. It's de-energized. But refrigerant's flowing. How can that be? It's like, okay.
Yeah. We ran it in heating and was operating fine, was heating the space. And I was like, okay, so in theory then, solenoid valve 4 should be open because otherwise we'd be deadheading. Yeah. So then I unplugged SV4 and ran it in cooling and immediately hit the restriction. And I'm like, how is that happening? And then it turns out it's a check valve. Makes all the sense in the world once you know.
See, I love things like that when you learn something.
Yeah, little Easter eggs.
Yeah.
These are the things you're going to find out when you come to class.
Yeah.
So make it a point to, even if you've attended M&P before, come to the new M&P class and you'll learn about these little nooks and crannies.
Yeah, absolutely.
Or listen to the podcast. Or do both.
Yeah.
Do both.
Or watch us on video now.
By the way, little side note here. The camera adds 10 pounds. I just wanted this. There's 3 cameras on us. So that's 30 pounds.
So does a cheeseburger lasagna.
Yeah. Doesn't help.
Yeah.
All right, what's next? I thought we could move on to indoor unit wall mounts.
Okay.
So this was something interesting that shout out to Scott Tallman. I don't know if you guys remember Scott Tallman.
No, he's dead to me.
Oh, okay. Yeah. He kind of brought it up in passing probably about a month before he left. Was like, hey, guys, just so you know, the new A2L wall mounts have CN1 S1, which acts like CN4F. And then he said, I'm out. And then we never heard from him again. Just kidding.
He'll be back.
So CN4F, we've talked about it on other podcasts, but it's your little jumper that we have in the indoor units. You can cut into it, strip back the insulation, and then use it as a wiring for your float switch.
Right.
It's a normally closed contact. You can use, the RectorSeal SS2 float switch like we use on the IntelliHeat. Or you could use like a wet switch and just use the normally closed contacts, but it's just something to break that normally closed contact. And when it does, it will tell the system, hey, we have a drain fault. It'll shut the unit down on drain fault. Now, we never had one typically with wall mounts. Right. We were always doing something with a thermistor or, we were breaking a comm line, a power line. Yeah. So now we actually have one in the FX, the GX, the EX, all the new wall mounts for the A2L models, there's a long jumper. It's actually really nice too. It's like 6 inches long.
Yeah, which is nice because usually it's like a half inch long.
Yeah.
You know, and I know it aggravates a lot of people. Me being one of them. It's like, how am I going to cut this and splice this and wire nuts?
And the wire's very thin, so it's hard to get a good wire nut on there. But this one, it's a lot longer and basically works exactly the same. So you cut into it, you strip back the insulation, goes to a normally closed float switch. If that were to show open for more than 3 minutes, you're going to get an error code. So
it's going to be a 4-time flash.
Yep. So indoor unit will do a 4-time flash. Outdoor unit will do a 9-time flash.
All right.
Yeah, but rather than being there on a service call and you have a open thermistor that you think is a bad thermistor,
right?
It's not a bad thermistor, and you're chasing your tail, and it's a drain fault because you're breaking the thermistor. Now you're actually getting a drain error,
a true drain error.
Yeah. And that's the thing too, is even if you are breaking S1 with that, it's still like
right. Yeah,
why did I lose a leg? And you still have to do that searching. Why did I lose a leg? And unless you installed it, you may not know that there's a third party pump somewhere. So
that's it for that one. The next one I found really interesting, right? We always had TH4 on the top of the compressor for the shell temperature, right? Thermistor just to shell temperature. But now we actually have a thermal protector or some type of normally closed switch. I don't know if it's bimetal, if it's solid state, or what it is, but this is something new. So tell us about that.
Yeah. So due to the refrigerant change, we had to have this thermal protector. It's right on the top of the compressor, typically right where the wires go to the compressor. And essentially, it's a normally closed switch, like you said, that will open at 248 degrees. So with P-Series and with Smart Multi, they have a thermal protector, but it is wired in series with the high-pressure transducer. So if it shows open, you'll get an error code, and the error code will start to direct you towards look at your high-pressure sensor and also check your thermal protector.
Yeah.
So because it knows it's in series, in the troubleshooting portion on the service manual, it will say check both of those circuits to make sure that they're showing closed.
Now, do you know, is it a bimetal or is it a solid state? Do you know?
I don't know off the top of my head, no.
All right. We'll edit that part out. We don't want anybody to,
Now, do you remember Tattletales?
No.
Tattletales were these little devices that you could put across safeties to figure out which safety tripped on you. Yeah, they sell 24 volt. Yeah, now, I don't know what the voltage would be on ours.
There would be a little plunger. There would be a little plunger of that was you'd put them in parallel with all your devices.
Exactly, because working. I just wanted to bring this up because the thermal protector and the high pressure safety are in series.
Yeah.
Well, that's typical on a lot of refrigeration systems, a lot of HVAC systems. You may have the whole string of safeties all in one or all in series, and you don't know which one is opening and closing because some of them are automatically opening and closing. Well, a Tattletale would tell you which one by putting this little device and wiring it in parallel with that switch. It'll tell you which switch is opening when you're not there.
Oh, okay. Yeah, that's helpful, especially like with a gas furnace.
Genius
you think
little
about all
device.
the safety
Anyway,
switches.
moving on.
But yeah, I do know I can't remember off the top of my head. I tested it. It's either 75 volts or 90 volts DC. I can't remember. I measured both AC and DC, and now I can't remember which one was
Typically,
AC.
previous generation, 75 volts with
DC.
AC potential.
Okay. That must be what it is then, 75 DC.
I'm assuming it's still the same, but we'll test that.
No.
Yeah, we'll get back to you in 15 or 30 episodes.
Yeah. Give us 9 months, and then we'll have another update for you. So the reason I brought this up, so possible error codes you could get with the thermal protector on a P-Series or Smart Multi would be a 5102 on a Smart Multi, which would be an F5 on a P-Series.
Don't you mean a 5201?
Yes, I do. Thank you.
Okay.
A 1302, 1302.
Yep.
Yeah. Could be a U1 on a P-Series, and then 6840 on a Smart Multi is an E6. So that it's communication side, but it will tell you in the service manual, check that thermal protector.
Okay.
And you're checking the thermal protector and once again,
That whole
the
circuit.
high pressure switch.
Yep. Now, difference with the M-Series units, M-Series outdoor units. They are not wired in series with a high pressure switch. They have their own connector and they have their own separate circuit. And what we found through extensive testing in the training center is that when that happens, it does not throw the same error codes. In fact, it will end up throwing a communication error. And then in the service manual, there is no mention of that thermal protector. So what I did was some digging into, okay, how do we actually navigate what happens when you have a communication fault? What should I do to make sure it's not the thermal protector? Because I can only imagine that at some point there's going to be a lot of boards that end up getting replaced if we don't properly diagnose this. And one thing that I found was a pretty telltale sign is that fluctuating voltage on S2 and S3 will drop, but not to zero. It won't be a steady 26 like the outdoor unit is supplying the voltage, but it's not getting it back. It's a constant 4 volts DC. Every single time I've tested it and failed, air quotes, that thermal protector, the S2 and S3 will eventually go down to 4 volts DC.
Interesting. And there's no mention of this. So
Unfortunately
if you're listening, this is something that keeping an eye out for. Don't condemn the board until you check that.
Yes.
Yeah.
Yep.
Interesting.
So that's a big one. So like I said, I tested it with the wires on. I actually took the wires off and checked. The outdoor unit puts out 20 volts essentially instead of the 24 to 26 that we usually see. It'll put out 20 volts, and then with the wires attached, I watched it happen where it actually, the fluctuating went from like 14 to or 12 to 24, and then slowly went down to like 5 to 17, and then it went down to 6 to, or 4 to 12, and then eventually it just kind of settled at 4. And I was like, that's so strange. So it's reducing that voltage, and basically the communication just stops.
Very interesting.
Yeah.
That's a good catch.
No. Very interesting.
Yeah. So one more checkpoint. Something more to check when you're looking at a communication fault.
Yeah. Yeah.
Right.
Keep an eye out
Don't
for that.
stop there. If I have a new system, an FX M series, basically, communication fault, just don't stop at S1, S2, S3. Look at your thermal protector.
Yeah. And another telltale sign, too, is the LEDs on your outdoor board completely go out. So there's no LEDs on the outdoor, which is another maybe indicator. No lights on. So the other thing about that thermal protector is when you reorder, so if you need a new one, let's say it failed open and it just won't close again, right? It's just a switch, so it should be able to close once we fall below that 248. But if it doesn't, you need to order the replacement. One thing to be aware of is that the replacement harness does not go all the way back to the board. There's actually an actual harness about halfway up the wiring, just like we do with our compressor. And so when you reorder the thermal protector, it only gives you the thermal protector itself up to that harness. It does not have the harness to board connector. So just be aware of that.
Okay. Sounds like it's easy to replace.
Yeah. Yep.
All right. And we actually have a picture of it that you're going to put up for those watching the video version of this.
Yeah. It's up right now.
Yeah. Okay.
Wow.
And what else we got?
That's it for the updates. Those are just some of the ones that I thought were the most important when it comes to dealing with that stuff. There's a lot of new changes going on. And again, we get the manuals and we live and die by the manuals. That's how we do what we do. But then when you test things, you see some variances, some things that maybe aren't as fully described in the manual. And so it's always helpful to get these out there so service guys or contractors have a better idea.
And once again, just to beat a dead horse, there is no propane in the A2L refrigerant. We were talking about this the other day. You still see people posting on social media. They don't get it. They're lying. I don't know why people get their thrills about lying and making stuff up and scaring people. But no, there's none. No. Okay. Just aggravates me.
Yeah. I had somebody, I think it was in class last week, said that. This is 454B and R32 were propane based.
Yeah. Well, yeah. Did you call him an idiot?
No.
I would have.
No. See, the thing is that I don't know if we all, as in the industry, know, but propane is not an A2L refrigerant. It is a B refrigerant.
Yes.
Explosive, not slightly flammable, explosive. And so to think, it's got to be partially because of it, because it's got flammability. Like, if flammability is fine, I'm okay with flammability. I can deal with that. I can handle the safety precautions. Explosive is a whole different set of concerns. So, like, weighing the two, they're not the same thing, even close.
Yes. No, you're right. Because there's the Fire Academy is not too far from where I grew up in Massachusetts, and they have this thing. I'd love to see it. I've never witnessed it, but I know a lot of firefighters. It's one of the demonstrations they have. They have a propane line that feeds into this open field, and propane's heavier than air. so it stays down low. And they got these little mini valleys, like these little dips in this field, and they flood it with propane, and then they spark it remotely. They create a spark, and boom!
Yeah.
It's like it's propane's powerful.
Yes.
At least with natural gas rises, so you know the chances are a lot. But propane's not good, you know. And people are afraid of propane. They were afraid of R290 as a refrigerant, but then they'll go get a gas grill, put a 30-pound can of propane right next to their house in the garage. So
Yeah.
I like propane as a refrigerant. It is a natural refrigerant. What's the global warming potential of propane?
0.
0.
Yeah.
Just saying.
Yeah. Until you combust it,
Yeah. Well,
which we don't want to do.
no.
But yeah, I mean, I think right now federally there's like only allowing like 1.5 pounds in systems for R290, and when it comes down the road, if it does someday, we'll
Yeah. The
just have to make the
R290
adjustment.
the R290 equipment that is currently installed and running in all over Europe is just like a pound, little pound and a quarter or something. Small amounts of propane in there.
Yeah.
They work great. But they're not houses blowing up left and right.
Yeah. See, the nice thing is so we covered this A2L updates, and then before long, teaser, we'll have a podcast about the City Multi A2L
Yes.
updates.
R32.
Yeah.
A couple months.
Yeah, we're working on that. We're actually working on that right now, working on a lot of things. I think the next podcast, Steve, you're going to talk about the
Air to water.
EcoDan Air to Water.
Excited.
Yeah, that's coming up. We're excited about that, working on that. We got a lot of things coming down the pike here, so
Yeah.
I'm looking forward to it.
Yeah.
All right.
So what did you bring for lunch today? Did you bring any lasagna with you?
No, I had Portuguese steak last night, and I didn't finish the whole thing. I had a good amount of it left. And
Is that what you sent me a picture of?
Yeah.
Oh, is that what that
Yeah,
was?
I saw that, and you know what words entered my head? Plop, plop, fizz, fizz.
Yeah.
No, it looks so good.
It was, and the thing is, I had a stuffed quahog and a cup of chowder before that. That was my appetizer, so I was already full. Like, oh man,
Isn't that what you had, Bryn, when we were in Newark? You had that Portuguese steak
I
at
was
that
just gonna
at
ask
that
you.
restaurant.
Yes, I was just
That
going to
was-
ask you, is that the same thing?
Yeah, we had the egg, the beef McAllen's with the egg on the steak.
This had
Yes.
2 eggs, a slice of ham on top of
Yeah,
sirloin,
that one had prosciutto
French
on it.
fries and rice.
Yeah.
So it's just
Yeah, it can't be.
And I sent a picture of it to Scott. And I said, if you were still working here, you could eat this. And you're never going to have this again. You're never going to have this steak plate again.
that same restaurant we're at in Newark.
Yeah.
The time before there I was by myself, and I had that steak. It was so tender, and the bartender told me, the secret is they marinate it a little bit, a dash of white vinegar, and something tenderizes the meat. It was so
Yeah, I could
so
see
good.
that. The acid
Yeah.
kind of breaking down the muscle
Yeah.
fibers or something. But
Yeah, I know. What's the other thing? What's that white powdery stuff? Not
MSG, cornstarch,
the Arm & Hammer stuff. I can't even think.
baking
of
soda.
Baking soda. That tenderizes meat as well too.
Yeah.
Not baking powder, baking soda.
Yeah, the potatoes on that were really good.
Yes,
were like-
they call those Portuguese fries. They slice them like thick potato chips,
Yes.
right? And those are wicked good. Did
Yeah.
you even finish it? I don't think you finished it.
I
did you?
know it was so much food. I ate all the potatoes though because it was in this like gravy,
Yeah. Oh,
sauce that was kind of
Yeah.
in the whole bowl, and those potatoes were like crunchy on the outside, like had a good bite to them, but then inside it was like a soft, fluffy mashed potato.
Yeah.
And then once it had sat in the gravy for a little bit and kind of soaked up that flavor, it was ridiculous.
Don't get Steve going on that.
awesome.
We went to a Portuguese restaurant and they had this steak and there was no gravy with it. He was ready to put out a contract on the chef.
Yeah.
How can you not have gravy with your steak?
I don't care what anybody says. Nothing beats a Pismo steak. Ask Juan.
This is why he doesn't come on the show because he makes up these meats.
Yeah.
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 Yeah. All right.
All right.
We'll see you on the next one.
See you on the next one.
Literally.
See ya.